Hi, everyone. Thank you all for joining us for this session. Please feel free to use the chat to connect with fellow attendees and to share your thoughts during this session. And if you do have any questions, please post them in the Q&A tab and we will address them afterwards. And now, presenting you with the presenter for the session, Shrikanth. Take it over.
Yeah. Hello, everyone. I welcome you to this talk from my side. Myself, Shrikanth. I'm a data scientist at Sixth, close to 2 years now, and mostly work with uh, marketing-related projects. To be precise, something like CLV, revenue prediction, and also to optimize the resource allocation to our campaigns that we have. So today we will talk about automating the SEA targeting to have or get smarter audience engagement and higher conversions. So to start with, this would be our meeting agenda. So we will start with the business context, where I will talk about SEA and what retargeting is in a very bird's eye perspective, so that even if we have any audience who don't have prior knowledge about SEA and retargeting, they can be onboarded. And then we will talk about data blueprint, as in what data do we use, where does it reside, where does it come from, and so on. And then third, we will talk about formulation of our ML statement. How did we solve, or how did we frame our statement itself? And then the output of a model being an audience, which we select based on their interaction on the website, and how do we upload them to which audience platform or to which advertising platform. And finally, we will show a brief audience performance analysis we had as an output of this project, and that's how we will wind up. So to start with the business context, a very bird's eye perspective of the background on how SEA paid search works. So on the right side, you can see website visitors who search for car rental. I mean, if you're not aware, Sixt is basically a car rental business where you have different products like rents, shares, rides, and also subscription-based products and so on. So if a user is not aware of Sixt itself, he might end up putting a very generic search term in the Google search. For example, car rental Munich Airport, car rental Malaga, and so on. And you would have seen, or you would have encountered some sponsored ads based on the query you put. And this is typically where SEA plays a role. These are paid ad placements, as in different companies bids on the search keywords, and based on the bidding, or based on who has bidded the most for a particular keyword, those ads are pushed up in the ranking, and that's what you see under the sponsored ads. And in this field, not just the amount of bidding goes into play, it's also the ad that you put in. It's also the website, how much relevant it is for the search keyword. And these everything is considered, and in on top of that, the bid amount is played. And there is also an essential factor, expected effects, as in whenever you place an ad, you also put multiple redirection links, also some contact numbers and websites and so on, and how effective they are. They also play a key role in the rankings. So it's not only about how much you pay for the keyword, it's also about the website and many of the background interactions that happen. And also here, to not to I mean not forget to mention, it's basically click basis, as in every company pays on a click, so it's called CPC, and that's the bid strategy that's used in the background. And eventually when you run a campaign on SEA, you typically have to analyze, or typically have to measure how effective it is. So on that basis, you measure the impressions, the clicks, the CTR, and conversions. Basically, they talk about how much reach your ad has. How much reach your ad has gone to, and also how much relevant your ad is to the customers. Only then they would click on your ad, and also the profitability, basically the conversions that you generate from this ad. And also not to forget the cost to sales, so how much cost has been incurred, and in return how much revenue have you generated from this. So that's a basic overview of how paid search works. And about the retargeting world, it's basically like if you're looking for a shoe, or even if you're looking for a car rental at Sixt, you wouldn't convert at the first instance itself. You wouldn't believe in the brand at the first instance. So that's why you might skip out from a certain stage of the booking funnel as in certain stage of your customer journey, because maybe you want to do research, you want to compare with some other providers and so on, but you skip out of the website, and this is a lost customer for us. So in order to somehow recall them about the brand and give a certain subtle push that they come back and book with us, we use something called as retargeting campaigns. These are basically campaigns where the customers can see our ads, not just on a social media platform, but also on the other websites or other travel booking websites. And how this is achieved is basically you have a retargeting pixel which is placed on the website, and it lands into your browser. And this retargeting pixel typically doesn't record any of your personal data. It's simply the IP address anonymized form, and this is used to show ads on different platforms where we are showing ads basically. So you go to Skyscanner, you see a Sixt ad. It's because you have visited Sixt in the past. This is an example of a retargeting campaign. And eventually you see a retargeting ad, and then you recall the brand, and then eventually you turn into a customer. So not all the retargeting customers convert. A ratio of the retargeting customers convert. So retargeting basically gives us another chance to show our brands to the customer, so show our brands to the past visitors and make them a customer in future. So that's the background about retargeting. And moving forward, the data blueprint. So what's the background data that we used for this project? And this is an overview of the Sixt booking funnel. There are more granular stages, but I have only listed the most prominent and most broader ones. So we start with the home page, where you have to put a rental pickup station and also the return details and so on. And then based on that in the background, we know, okay, you're looking for a location, for a branch, for a specific branch, and what are the different vehicles we have in our fleet. So you choose a particular vehicle type, say BMW, and you also have to select the mileage package. So how much mileage do you want? Like it's limited, or you want to have a custom mileage package or an unlimited ones, and also the payment type and so on. So you create an offer for yourself, and then you go into the offer configuration page, where you can customize based on the protection package you want, like the insurance packages, and also add-on selection. Like if you have a child, then then you want a child seat. And for example, if you're going for a long travel, then you have an additional driver with you who can drive, and you can share your driving. So you can have an additional driver add-on option, things like that. And eventually you're happy with the reservation details, you're happy with the price, then you enter your driver details. So that's the final checkout process. And then you have the final booking confirmation. And you can also see the booking intent starts from a less motivational perspective, and eventually you turn into a customer because you're satisfied with the product that we're offering. And moving forward, so you're interacting with the booking funnel. But how is this data consumable? How is it made consumable for us? So basically, you start with the front end tracking via data layer. This is nothing but if you inspect your own Google tab, you can go and check in your data layer what is being tracked from your system. So it's nothing but a key value pair, where keys are basically the descriptive names of the data points that you interact on the website, and values are nothing but the values that you choose for this specific parameter you want. Say in the previous page, you can see you have a vehicle select. This becomes the key pair. This becomes the key, and the value would be a BMW. So that's how the That's how data gets tracked in the front end, and it passes through our customer data platform, which is a data aggregator, because we don't only have a presence on the website, but we also have app. So that's why you need a data aggregator in place, which enriches and eventually which and then eventually lands up into our cloud source cloud provider, which is AWS S3. And from the S3, from using Athena queries, we somehow construct our online browsing purchase behavior per client per timestamp, because these are online stream data, which comes in a range of every millisecond. Therefore, every row would represent behavior, and the forthcoming row will not be a row from the same customer, but from a different customer, because it's tracked every milliseconds. And then you land up having events from multiple timestamps per client, but you have to detect them and aggregate them together to eventually have what is called as user journey, which is created per client and per session. And here session is a window which basically defines your inactivity period. So if you're inactive on the website for a period of say 30 minutes, then you are assigned to a different session ID. So you have to work on this and frame this window. This 30 minutes is not a static one, but depends on your use case. So for us, it was 30 minutes inactivity, and that's what we use for creating sessions for the user journey. And moving forward, so now about the ML problem. Now, even before going to the ML problem, let's see, why do we need ML in this case? So to talk about that, so basically, what we intend to do is we want to find smarter audience who have high probability to convert, and this cannot be simply taken from the depth of the booking funnel you have reached. Say you're on the stage of vehicle selection. A customer is in the stage of a vehicle selection, whereas the other customer is at the stage of add-on, say adding an insurance package. This does tell about the booking intent, but doesn't tell us about how likely this customer would convert. So that's why we use ML, which would uncover our hidden relationships between the behavior, and truly indicate which purchase intent would redirect us to the conversion likelihood. And second would be to automatically update our audience, because the booking behavior is not pretty constant over the year. It typically changes because there could be various reasons. One could be that it's a highly vacational season, where there is a lot of customers booking, but with a very shorter time window. Then this evolving customer behavior has to be considered into the data, and this is done automatically in the backend because of the features that we use in our ML model. And now these are very I would say one or two advantages of using ML, but there are quite a lot. I wanted to mention these two because we have a tremendous output or consequential output because of this. Now we have our high propensity customers, as in customers who have high probability to convert. And now using that, what Google does in the backend, so when we upload this high probability customers, Google uses this audience as the seed audience. Basically, you can consider this as a root audience, which Google uses in the backend to find similar audiences as in audiences who have a similar booking behavior, similar conversion behavior, and maybe are looking into the similar products in the backend. And and basically, Google propagates the knowledge that this seed audience has and reaches the similar audiences, eventually maximizing our ad performance and resource efficiency. And the second would be data-driven attribution. This is the principle that Google uses in the backend to attribute to a particular campaign that a user converted. Say a user has seen our ad, sixth ad on Instagram, Facebook, some other travel booking website, but you can't simply attribute to one of these touch points in the journey. So what Google does is it has a data-driven attribution, which typically weighs how important a component in this journey is, and then gives the attribution to these channels. And that's a basic understanding of DDA. And what impact can we create using the high propensity or high probability customers is we are in the back end trying to cross impact the audience. So cross audience impact, which means that it's not only the audience in the Google that you have added, it's like the audience from multiple sources. There could be an SEA manager adding a rule-based audience, say that customers who have reached the booking funnel, say add-on as an example, is more of a valuable customer for us. So this becomes an audience created by an SEA manager. So there will be multiple audiences in the Google Ads, and one audience from us would be the high probability customers. And because of this presence in the campaigns, DDA will transmit the greatest influencing factors that our audience has, and will use or transfer this knowledge to the other audience. I can say an example for this. Say there is a keyword, specific keyword like vacation in Malaga, for example, and the audience that has been added by our ML model is generating more value using this keyword. So this is a knowledge from the audience that we have pushed to the Google Ads. Now, what happens is this knowledge is transferred to the other audiences also. And when the other audience search for that specific keyword, they are also shown our sponsored ads. So that's how we can impact the other audiences also, because of our high probability customers. And this is why we want to use ML for the audience selection. So moving forward, so how do we see this as an animal objective? So we can say that this is a propensity modeling where we are interested in the likelihood of conversion given the user's interaction on the website. In the context of knife base, you can break it down. So what we are interested is in the first row, P of conversion, probability of conversion given the online interaction. This is the posterior probability. We have the prior probability, which is probability of conversion, and we continuously update it using our observations as in probability of observations, which is online interactions given the conversions. And eventually we have to normalize it, because not a specific set of interaction will always will be representing a converted customer. There can be similar online interactions which might result in non-conversion also. Therefore, you have to normalize it with the evidence we have, which is the probability of interaction. And when you translate into decision trees, because we didn't use knife bayes, but the formulation was through the knife bayes, and when you translate it into decision tree context, so it's basically what we want is the predicted probability at the terminal node of the tree, which is the posterior probability. And then um, and then yeah, this observation probability of online interaction given the conversion is typically implicitly modeled by the splits on the feature to maximize the information gain, um, because feature splits happen based on the observation that has been seen for the subset of customers where we want to maximize the information gain, or in other words, lower the entropy. And probability of conversion is the root node we have, where the data splits into 80-20, depending on 80-20 as in, if you say that 80% of the customers are non-converted, then all the data belonging to that falls into that, and the rest 20 on the right, something like that. And when you consider decision tree, there is no need of normalizing, because it assigns probability at the leaf nodes, and that's the evidence for us. And moving forward, yeah. So now about the feature formulation. This is analogous. So we have two set of features currently, two groups of features, I would say. One is the online activity features, and the second is reservation parameters, which is basically like pickup location or pickup type and so on. You can have this as an analogy where it's very similar to the um, movie sentiment analysis, where you have different words in a review, and these words already indicate about the sentiment. So in the world of online activity, you can consider this as number of offers viewed. So if you remember in the beginning, I mentioned that you create an offer for yourself based on your requirement, but this requirement can change, and therefore the number of offers created for this will also change. And therefore you have number of offers viewed and number of vehicle selects. Say you change your vehicle in the customer journey, so there is this count factor also involved, like how many times do you change your vehicle selection, and also number of changes to the booking location and time, because there can be price changes. For example, a high touristic place might have higher price for a car rental, whereas uh, whereas I mean yeah, the other stations might not have that much price. So in that case, you might change your booking location and time and so on. And the reservation parameter features. So this also indicate about the intent of conversion, because conversion dynamics may differ for a business traveler booking for the airport pickup compared to a tourist. So this is also taken into account through our feature engineering. And also maybe last minute bookings can also say whether a customer is intent to convert or not. And also weekdays and weekend bookings can also impact our conversion. So we take that into account under the set of reservation parameter features. And all other online activity features are basically count of them very naively, I would say. And moving forward, yeah. So now when you construct your customer journey, there are challenges with it, because you can see that if you remember, I mentioned the booking funnel where the intent increases as you go deeper into the funnel stages. And this intent can already leak information to your target, basically convert or not convert. So so this can already talk about your intention to convert or not. So therefore, this would create an imbalance in your feature set, because certain events are present only for the converting customers, whereas certain events are not present for the non-converting customers. So this feature imbalance has to be taken into account and should be mitigated, because this can also overfit your model to a less minority class, which is converting customers. And how do you mitigate it? You typically limit your feature scope to pre-conversion behaviors, that is early and mid funnel events observable for both converted and non-converted customers. So you pick that sweet spot where there is a trade-off between conversion and non-conversion, but you also take into account the features which is balanced for both the groups. And moving forward, this is our model training pipeline, and it's so this is from the previous feature engineering, where we have the user journey per client. And what we do is we use dask data frames, because this event stream data is consists of millions of rows. Even if you increase a quarterly data, even if you increase a data set by 1 month, then millions of rows gets added up. So therefore, we have used Dask in this place, where we convert pandas data frame into Dask data frames. Keep in mind of splitting the data frames to have a larger partition, because larger is better. And also, if your data set has an index, use that, because this would be essential when repartition occurs while conversion. And you do a basic schema inference, which is used during your data cleaning and feature engineering, and you map these partitions, and basically you map these partitions to the modules that you want to do with this data. So basically data cleaning and feature engineering. And eventually the output we have is what I mentioned in the feature formulation. And we split this data into 3 country groups. So a country group consists of 3 countries. This is because we wanted to have a split based on the similarity of the performing market. And finally, we train a cat boost regression model on this data set. We make sure that we use these parameters, because these parameters are important to counter the imbalanced data set that we have, and also the log loss function, because we are mostly interested in the conversion probabilities, not the labels. Yeah, that's the 2 reasons that we fix these parameters, and we fine tune our model using Bayesian optimization. And eventually we have our trained model stored in the S3 buckets. And the audience selection, I wouldn't repeat the existing one. So we use quantile based selection here because we want to know, we want to tweak our campaign size. If we want to focus on high probability customers, then we pick the higher quantile. And if higher recall is required, as in larger audience base is required, then we fix our quantile to be lower. So if you fix 80% quantile, 80th quantile, then you're choosing top 20% of the customers to retarget. So that's how we tweak. And once we have the selected audience, we upload them to the Google Ads. And this is a technical slide. You can go over it offline. I can also share the link where I got this from. And it's a pretty straightforward way how you can upload automatically the audience to the Google Ads by creating one user job, and you keep uploading your audience list every day to this. And one thing I forgot to mention, so Rita, we focus on non-converted customers from the previous day, because the intent of retargeting should be on the spot. Like it should, the interest towards the brand might decrease as the day progresses. So we retarget the non-converted customers, especially from the previous day. So finally, the audience performance analysis. So we have an existing rule-based audience where audiences are created based on the stage of the funnel they exited from. So say a user exited from offer configuration, then the user is added to the audience funnel offer config 360 days. The 360 days is nothing but the membership, that is the validity of this user to stay in the Google Apps domain. On the other side, there is an audience which is picked up by the propensity model. So remember I mentioned that there will be a data leakage issue. So what we did is we limited our features for the model until the offer configuration booking funnel we have. And that's why we compared the performance between the audience, which was created from this booking funnel stage, with respect to our audience propensity model 360 days. And the results we have for from March to November 2024, only for non-branded campaigns, is we had an uplift of 9 percentage, and conversion rate uplift of 113 percentage, reduced cost per conversion of 22%, and overall spend on ads reduced by 30 percentage. I wouldn't say that our approach is the best, because the amount, although the ratios and percentages look drastically high, but there is a population size also. We are choosing very niche, I wouldn't say niche, but very precise amount of audiences into the Google Ads. Therefore, our absolute numbers are a bit low compared to the other audiences or rule-based audiences we have. And maybe what I can say is that if you want to go for broader audience, then funnel-based audience creation is the go rule. Otherwise, if you want to have a precise audience and low budget campaigns, then go for the propensity-based audience selection. And these were the references I used. And if you want to reach me, then that's my personal email address and a LinkedIn QR. Thank you very much.
Thank you so much, Shrikanth, and thank you so much, everyone, for joining us. We are going to wrap up and we head over to the keynote. So, thank you so much. If you
Mhm.
have any questions, please let us know. Bye bye.